All right, good morning. Unfortunately, I am out again today, but I should be back tomorrow to celebrate Pi Day with you. And um, thank you to those who did what you were supposed to. I appreciate it. Please watch this video. It's not hard. It's going to be pretty short, and then there will be a few practice problems. So today is the equivalent of what we did yesterday, except instead of for circumference, it's for area. So much like yesterday, we don't want the entire area of the circle, or yesterday it was we didn't want the whole circumference, right? We just wanted the chunk for the arc that we had. Well, here I just want the sector here shaded in green. Okay, so if we look here, our formula, pi r squared, that tells us our area, but we only want a percentage of the area, right? So theta divided by 360, that'll give me just this green sector. Okay, so hopefully it's pretty easy. If you look here, the important thing to realize is which one are we solving for. So here we're looking for the shaded part. Okay, so that's the 300 degrees. Okay, if we were finding the white part, we'd use 60 instead because the total is 360. Right, so 360 minus 300 would be 60 for that white part. But we want the shaded part. Okay, so if we think about it, pi r squared is our formula for area. So pi times 9 squared. But instead, we're going to have 300 divided by 360 times pi times 9 squared. Okay. Once again, desmos.com/scientific. That's a great calculator, in my opinion, if you don't have access to one of mine. But if you're in my classroom, feel free to grab one, the blue ones. Okay, so pi gives you pi, or you can see it's right there. So 300 divided by 360 times pi times 9 to the second, or most of you know 9 to the second is 81. Okay, and we get 212. If we round to the nearest tenth, it'll be 212.1. Now, we need to remember this is area. So if it's area, we know it's not meters, it is meters squared. Every time you are dealing with area, you are going to square it. Okay? All right. On our second one, same approach again. This time we're using 160, so 160 over 360 times pi times 6.5 squared. The fact that it's a decimal doesn't change it. It's still just 6.5 times 6.5. So 160 divided by 360 times pi times 6.5 raised to the second. And we get 58.99. So when we round to the nearest tenth, it becomes 59.0. Once again, meters squared. And make sure you square your area. Now, the good thing is on delta, that won't matter because on delta, they don't make you fill in the area. I think they probably already have it done for you. So as you can see, it's pretty simple. All you got to make sure you know is what's the angle and what is the radius. As long as you know that, you can do it. So this one is actually the same as the first one, except instead of 300, it's 20. So I'm just going to change that. So we'll get 14.1. Now, on number 4, we need to make sure we check this one carefully. And don't forget to square it, right? Okay, number 4. There's a difference here. First off, there's no picture, but that shouldn't give you a problem. But the difference is they gave us the diameter. It's easy just to get in the habit of just putting everything into a formula, right? We need to, instead, we'll have 315 divided by 360 times pi, but remember, it's r squared. So we need to do 27 divided by 2 to get r. That comes down to 13.5. That is our r. Okay, so now if I use that, 13.5 squared, we will get our answer. Okay, so let's go down here. 315 divided by 360 times pi times 13.5 raised to the second. And we get 500.98. So if we round to the nearest tenth, it will become 501.0. Still meters squared. All right, on the back, there's one last problem. For this problem, we're instead solving for the radius of this sector. So if we know that the area of the sector, which maybe I should have clarified that. So that's the area of the sector, not of the circle. Okay. So our formula for the area of the sector would be 210 divided by 360 times pi times r squared. We don't know what r is, and we know that is equal to 13 pi. Well, at this point, I hope you see we can get rid of our pi's. Okay? And now we need to solve for r. Well, we need to get r squared by itself so we can take the square root. So right away, if you notice 210 over 360, you could cancel those out. If you didn't see that, it's not a big deal. But then we times by 36 over 21. If I do that, I need to do it to the other side. By multiplying by the reciprocal, it causes everything to cancel out. So we're going to have 13 times 36 over 21. And as you can see, we get this decimal. Okay. Now, we need to take the square root of that. Okay. So if you're doing it on here, if you type in SQRT, it pops up. You guys know how to find it on the calculator, square root. So square root, I can type A and S, and it will take that previous answer. For those doing it on the calculator, you're probably going to need to type in, oops, I put the wrong letter there. So if we put like 22.3, you'll see it's very close. Obviously, the answer is not exactly the same because we rounded, but for our purposes, it will still give us 4.7 as our answer. So r squared equals that 22.3, and so then when we take the square root, r equals 4.7, and there was no label here, so we can just say 4.7 units. We know it's not squared though because it was not area. So all right, there's a few practice problems. Once again, shouldn't be too hard. Lots of you got it done yesterday. Good job. Those who didn't do it, come on, try to finish up. These days were pretty easy. I know spring break is close, but let's finish strong. All right, have a great day. Bye.